The structure of water, though, is more inclined to the crystalline, and this is a work which was done by some people studying homeopathy in Germany. And water, in fact, forms what they call temporary modes of crystallization. So it's closer to being a solid than it is to being a gas. And in water, there are holes in which some consider that memories are retained in those holes. So that water has, this is how, for instance, homeopathy works with water, that the mother tincture or the resonances of the mother tincture are carried within the water molecule. It is really the resonances that are transferred when a medicament, a homeopathic treatment is manifested. It's not the mother tincture anymore. There is quite a work on that carried out by Jacques Benveniste at Paris University. Heat, on the other hand, is always the great harmer of living things. This is just a quick example to show a vibrating plate, metal plate with sand on it. That corresponds to a particular frequency, so those forms, they're Chladni plates, they're called. So those forms there correspond to whatever frequency the plate was vibrated at. But when the plate was touched very gently with a blowtorch, then the whole of the system completely went kaput. So heat, too much heat, of course, is a destroyer, and in particularly in terms of water, because water, as I said before, when the oxygen in water becomes when the water becomes too warm, the oxygen becomes aggressive, and then you start the destructive phases of things. Also, the way of moving water, either centripetally or centrifugally, has an effect on it. It's not so evident from these pictures, but I haven't got any better ones. But centrifugally killed water, as Viktor says, you can see it's all sort of fragmented and broken up into pieces, whereas water which has been moved under centripetal forces becomes vitalized, and it is far more coherent. This also, I suppose, under the magnifying glass would produce something of the same sort of structure we saw in the previous slide. This temperature gradient, though, which is critical to water, and let's see how we can even achieve it in the atmosphere. We're taught when we move up that it gets colder, but you see it does get colder periodically, and then it gets warmer as we move up. So there is actually a fluctuation, an alternation between heat and cold as we move from the outside of the Earth's atmosphere down towards the center. Down towards the Earth's surface, and each of these points where you go, for instance, from the temperature of minus 90 degrees to plus 10. So here there are points where you have this 4-degree anomaly point where water could exist, and in a sense, I'm afraid I won't be able to explain that because I've left the other slides behind. I'm sorry. But in that process, a condenser, what Viktor or Walter would have called a biocondenser, is created, where the energy of the sun is magnified as it gradually approaches the Earth, so that the energy matrix that we live in, where we are, is dense enough to support the life forms which are necessary to be here. Again, this temperature affects and the variation in temperature in water, of course, affects the whole of the climatic situation, because when the temperatures rise, there's too much evaporation, and then we can have flooding and droughts under certain circumstances. And Viktor had two ideas, had different ideas about the so-called hydrological cycle, because the normal hydrological cycle is one where the rain falls, it falls onto the ground in the forest, it goes underground, it evaporates from the trees, it evaporates from the ocean, rises to the clouds, fall again as rain. And it also goes underground and charges up the subterranean water table and the aquifers. And the problem today that we have is that this cycle now is no longer the full cycle, but the half cycle. And the half cycle, there's no penetration of groundwater, of rainwater into the ground, because the temperatures are wrong and do not allow it. Now this comes back slightly to the temperature gradient. You see, if the rain, when it falls onto cold ground, cooler ground, if the ground is cooler than the incident rain, then the rain will be absorbed into the ground. But if the ground is warmer than the incident rain, then it's like dropping water on a hot plate and it skitters off sideways and there's no penetration. So as soon as you start taking the trees away, then you of course arrive at a position where there's no water retention, there's also no water penetration through the ground, and there's a rapid re-evaporation because more water is exposed to the sun. And so in the half hydrological cycle, which is really gripping the whole world at the moment, you have a situation where you have flood or drought, or flood or drought, or the result is that the huge agglomerations of water are non-uniformly distributed around the planet, and we get this massive disturbance in the climate. The temperature gradient again is very important in the formation of springs. There are two forms of springs shown here. Seepage springs are what we are normally referred to as springs, where water penetrates under positive temperature gradient into the ground, meets an impervious layer, and then flows off according to gravity to wherever it comes out of the side of the hill or wherever it appears. But a true spring, a true mountain spring, is one which can actually arise at the top of a mountain, and it can discharge an enormous volume of water all year round, although there is no catchment area sufficiently large to produce the flow that comes out of it. Now, in Viktor's explanation of this, you have under a positive gradient, temperature gradient, rainwater infiltrates into the ground, and as it does so, it cools until a body of water is formed in the ground called the groundwater body. The lower form part of the groundwater body, however, those layers of water, horizons of water, are heated by geothermal heat from down below, and so the water below the groundwater body, the bottom layers of it, wants to expand, and that creates an upward pressure. On the other hand, there's a downward pressure from the water lying above the main body of groundwater, until finally in the middle is this 4 degrees centigrade, and at this temperature water is at its most dense and incompressible. So it is actually squeezed between the geothermally expanding water from below and the overburden of rainwater infiltrating from above, and it's squeezed, and the pressure of it will cause it to come out at the top of a mountain. And that is the formation, the reason for the explanation of the formation of true springs. There are other factors here too, in that in the process of infiltration, the oxygen in the rainwater is gradually removed by the plants and the various organisms, and so when you get down to the groundwater proper, there may be virtually no oxygen in it at all. And oxygen is, as I mentioned earlier, the fertilizing force from the sun, a male aspect, whereas the water itself is female. And there comes a point where there's such a hunger of the water for the male oxygen that it is also creates an attraction which draws the water to the surface at the spring on top of the mountain. This can be reproduced, how this actually happens, quite simply. If two bottles are put together, you see when the rainwater infiltrates into the ground, it also pulls all the salts down with it, and so in the process of absorbing and dissolving these salts, it becomes specifically heavier itself. That means that it actually, per unit volume, it is heavier than the equivalent of fresh water. And if you fill the bottom one with fresh water and the top one you put in only a substantial amount of salt, and this capillary tube is inserted before you put the salt water in. Once the salt water has been put in, then fresh water will drop out of the top here, actually above the surface of the salt water. And so that explains quite simply how the spring occurs at the top of